Hi guys, and welcome back to Aid's Workshop. Okay, I think today we'll start, as we've done many times, with a few new bits and pieces that have arrived. So first of all, I keep getting asked, where did I get this, where did I get that? So let me announce to start with. These were from Arc Eurotrade. That's arcerotrade.co.uk. Arc Eurotrade. Right, okay, so we got that out of the way. Yeah, hang on, I haven't even opened these up yet. Let's open one up. ER32 hexagon block. Let's bring that into shot for you. Yeah, ER32, ground on all sides, ground inside everywhere, hollow through, hexagon block. I've also got, let me just bring the other one out. I won't bother taking this one out of the packet, but it's square brother, ER32 square block. So after those, along in a kit, they basically do a pack where you can buy both blocks and one ER32 collet nut, but it's the ball bearing type. I went for the ball bearing type collet nut. I've sort of read reviews and what have you, and it seems the ball bearing ones are so in some way better. Okay, so yeah. I'm sure the hexagon block's going to come in handy. You've seen me milling hexagons at various times on the lathe, but yeah, it gives me the the chance to be able to mill hexagons, squares, what have you, flats, that sort of thing, on the milling machine. So that's those two. Okay, a parcel has arrived. I can't spit my words out today, from one of my subscribers. Now, he regularly sends me parcels, and it's Stephen. Thank you very much, Stephen. And I'll show you guys the contents of the parcel. So yeah, big cardboard box, various bits and pieces. We'll go through them one by one. I'll try and make this as quick as possible. Yeah, an ER32 collet on an MT2 taper with an MT2 to 3 collet sleeve. So I could use it in the milling machine, or I could use it in the lathe. And this would have a 10mm drawbar. So yes, I could use it in the mill with the sleeve. My slight concern would be the sleeve might get stuck up in. I don't know when I'll think about that at another date. Right, so that's an ER32 chuck with the nut, which is brilliant. Okay. So a milling cutter arbor for a shell mill. Again, MT2, so lots of options for that. Yeah, I mean, loads of options. Just a further thought, an option for the ER32 by MT2 collet chuck would be I could use it for drilling in the tailstock of the lathe, so that's another possibility. But yeah, a milling tool arbor, so I'm sure I'm going to find a use for that, whether it goes with the tool I buy or whatever I use it for. It's definitely going to be useful, so thanks for that. Let's put that back in its little box. Again on MT3 now, a great big chunky fly cutter on an MT3 arbor. It's got a couple of angle cutters to take some round tool steel by the look of it. Yeah, so it would probably take various round tool steels in a fly cutter arbor direct to MT2. I do like the design of that, and I think if I go to make my own fly cutter or modify this one, I do like the fact that it's straight onto the MT3, sorry, or I think this is MT2, actually, looking at it. This is a plain shank, so not a problem. But I do like the idea of having an MT3 arbor direct onto it as one piece, so maybe we can make use of that. Okay, well, I'm sure we can make use of it. Oh, lovely little pair of Moore and Wright calipers, external calipers. Yeah, add to my caliper collection. Right, let me just go into the box here. Make sure I haven't missed anything. There's another carrier bag to come yet. Little dormer cutter box. Oh, a little dormer end mill. And that looks about 10mm. It's probably Imperial. It is actually a 10mm end mill. Looks in really good nick. So yeah, that's brilliant. Little high-speed steel end mill, dormer 10mm. You can never have too many sharp cutters in the box. I've got a packet here of, I have seen these, various parallels they're ground one side. They're all stamped up on sizes. I mean, there's a pair of 7/8 parallels, 5/8. Yeah, various different sizes of parallels. Little short ones here, ground on all sides. I'll check those out and they're going to be handy. But yeah, quite a good collection of parallels. So I'm sure I'm going to find those very useful as well. You can never have too many parallels either for setups. So, right, let's just move the box out of the way. That's the parallels and one cutter. And if I go into the bag here, oh, let's pull them all out, make sure I don't lose any. Yep, got the lot. Yeah, a large collection of milling cutters. Various sizes of loose ones. There's slot cutters, end mills. Yeah, some nice long series ones here. They're all Imperial. These are 3/16, that sort of idea. 3/16, 8. Nice ball end mill. It looks in really good condition again. What size is that? That'd be interesting to know. It's a 3/8 ball ended end mill. Very useful. What looks like an 8mm slot cutter. Some more small end mills, a quarter, long series quarter. What looks like 3/16, so maybe even an 8. I think there's a 3/16 here somewhere as well. There's some of these little, I don't actually fully know what they are until I open the packet. They've got a serial number on them and a Chinese what's it. So, yeah, I think they'll have to remain a mystery for the time being. They look like little inserts. They're little angled inserts, whether they're a form tool of sorts or what they are, I'm not 100% sure. But there's 1, 2, 3, 4, 5, 6, 7, 8 of those. And again in a tube, oh, a nice larger ball end mill. 9/16 high-speed steel, again a Dormer one, virtually looks brand spanking new. So that again, very useful. You never know when you want to cut a little radius, and ball end mills are pretty much the simplest way to do it without jigs and fixtures and all that. So Stephen, thank you very much indeed. Much appreciated. You know, stuff keeps coming, and all I can say is thank you so much for all your support to the channel. Okay guys, on to the clamps for the new Vise. Now I've toyed with 2 or 3 different ideas. Let me just grab the Vise. Yeah, I mean, as you remember, there's no slot on the side, just a set of holes, which is where the pin goes through for the various positions of the Vise. I tried with ideas of picking up on the pinholes with sort of finger clamps, that idea. Then I toyed with the idea of the sort of cam clamps, which rock against a backstop and pull or push down and clamp on the part. They can be a bit of a pain when you want to come and clock things up, because you sort of nip it down, and because they're acting on the side of the Vise on an angle down like that, it's always, as you tighten and loosen, going to move the Vise around, and you can play with the tightness on both sides. But I didn't want to go down that route. So what I've decided to do is, there is an opportunity here underneath the fixed jaw to clamp in a conventional manner, so I'm going to go for that idea at that end. And this back end here, without undoing it, I'm unlikely to need to use this sort of back 20mm of the Vise. I mean, I won't be milling stuff that large, and if I am, I'll clamp it to the bed anyway. So I'm going to use a similar clamp on the back. Does provide slight problems in that my T-slots are inboard of there, so I've come up with a plan, and I'll show you where I am so far with it. So I've just machined this piece of bar. It was 25mm square to start with, or I think it was inch square, but it's sort of 25 now by 22. That's another story. Basically did it in exactly the same way with the roller, did 4 sides. When I got to the last side, I've done a few little features on the top here. I've put a shank for both sides, and I've machined away. It's 22.4mm, and I think I've gone down to 21.4 over this portion. Don't know whether that shows, you can see there, this is just a sawn end here. Yeah, I've gone down, so this is 22.4 or 21.4, and it's 25 this way. But yeah, just blocking up in the conventional manner, and that step was done again with the fly cutter, so it leaves that that little 45-degree fillet in the intersection there, just the same as you saw me do before. Oh, somebody commented on one of my videos, it might have been a couple ago now, I don't know when this one's going to come out, that, oh no, I don't think your head is lined up like you say it is, because I haven't seen the swirls in both directions for the trailing cut. Well, I don't know how well it shows, but yeah, there they are. All right, so let's put that to bed. The head is square. So we've machined this up basically as one piece, although it's going to be cut into four, because I'm going to have a clamp on 4 different corners of the new vise. So yeah, I'm going to basically get a cut-off wheel up in the grinder, and I'm going to cut this off into 35mm long pieces. In fact, yeah, I'll measure up what I've got. I could probably do 40mm long pieces, and I'll have a bit left over. So yeah, it won't hurt, and the bit left over won't be much use to me. So I'm going to cut it, change your plan. I'm going to cut them nominally 40mm and then just clean them up afterwards. So I've cut the 4 blocks off, and I'm going to mill the ends square. So using the bottom face, the side without the step on obviously, I can just drop the parts in. Now, slightly different to the last time where I clamped the 1, 2, 3 block to the bed. There's an M6 hole in the side of the vise. The vise is square, so I've clamped the 1, 2, 3 block to the side of the vise, so I can bring the block over, even though the other end of the block isn't square, push it hard against the 1, 2, 3 block, tighten the vise up. Where's my Allen key? Excuse me. Here we are. Well, I'm using a 6mm Allen key in my vise at the moment. Yeah, it fits the hole nicely, so it's fine. And that's now ready to machine. So yeah, fly cutter again. My tool hasn't arrived yet from Banggood, so it has taken over a week. So I'll just centralise the tool. Okay, I brought the column down to almost touch there. It's within a mil or so, and we'll start it up. Tend to run this about 1100. It seems to like it on this. I don't think I've mentioned this. And again, this is a piece of EN8. It seems to cope with it quite nicely. Just touch off. My chopping off with a cutting wheel was a bit out of square. I would like one, to get a bandsaw or power hacksaw here, but it's literally, it is having the room. So yeah, until such time as I got more room, I can't see me having any more room anytime soon. But yeah, when I get pieces of metal like this, it's either hacksaw or chop it off with a cut-off wheel. Nearly there. I'm only using the 1/2 of the cutter here, not running it right off, just for time really. When I do a finishing cut, I come right off the end. Okay, so that is cleaned up, and it should just drag across the back edge. So now I'll do a little tiny cut, maybe 2 thou, so it's not getting the knocking effect, and run the cutter back off the other side. It's just scratching and putting that cross-hatch effect in. Okay, so I'll do that to all 4 now, flick them over, and then do them all to the same length in exactly the same method. So I've blocked them all up. Think of the fly cutter as a great big 45-degree bit at the moment. So again, still against the stop, a height set, distance in and out set, all locked. Basically, I've chamfered that edge, You can see there, 45 degree. So no adjustments being made, just rotating in the vise and machining the 45s on around the outside. I can't do this space because of the step, or not yet. I don't want to alter the setting, so I'm going to do all 4 blocks, doing all the flat faces on both ends, and then I'll make an adjustment to cut across the chamfer on the stepped edges. So yeah, that's that block done. 3 faces on the bottom, 3 faces on the top. I've done one of the blocks already, I believe. Let me have a look. Yeah, I've done one other block, so 2 more to do up to that stage, and I'll make an adjustment. So yeah, basically take another block, no adjustments being made, and that way all my chamfers will be exactly equal on all of these edges. So the final operation, I've just changed it all around a bit. Chamfer on this edge here. I'm now travelling front and back instead of side to side, all clamped up. Again, 1 pass and the chamfer's on. Pop it out the vise, flick it in the other way around. Like pushing against this 1, 2, 3 block and against the back as I tighten. And just machine that little 45 degree chamfer on there. Yeah, repeat that operation for the other 3 blocks, and I think that's the machining or flat surface machining on these blocks done. So these blocks need 2 holes drilled through them. I've got them on a pair of those new parallels. I just mic'd them up, they were absolutely fine, top and bottom wise obviously. So yeah, wobble pin. I'm just coming in here and I'm going to pick up this edge. These holes are different distances from this edge, so I'm going to do them as sets. There you go. Right. Let me just lock the table in this direction. Set to 0. Okay. I'll just stop the cutter there a moment. Right. My distance for the first hole is 11mm up from here and 11mm in from there, and this is for the cap headed bolt. So I'll just unlock my carriage again now that I've set to 0. I already removed the backlash, so that's 3, 6, 9, 9.5, 10, 10.5, 11mm on the dial, and I'll lock the table once more, lock it solid. Okay. Right, I need to pick up on this edge now, so exactly the same procedure. And I just realised I didn't allow the 1.25mm for the ball. Okay, it's a 2.5mm end on the unit, so I didn't allow for it. So yeah, nearly made a boo-boo there. Let me just lock the table. Backlash is out in this direction. Okay, so this time I'll come across 1.25mm. That's 0.5, 1, 1.25, then reset at 0, I don't have to do this. I could have just come 12.25, but anyway. Right, so let me just get that out of the way a minute. So now that I've reset the 0, I know that the spindle is on the center of the edge. So now I can do 11 mil on this axis. So that's 3, 6, 9, 9.5, 10, 10.5, 11. Okay, right, lock that axis off and just come the further 1.25 on this axis, a further 1.25 this way. It's the treble, that's 1.25. Okay. I'm just going to set these dials to 0 so I'm not confusing myself. Okay, so both dials set to 0 and I've got my position here of 11 mil in and 11 mil in, and that's where the first bolt is going to go. So I do a quick dummy test. I'll just start the cutter up. Oop, too far. Normally put the pointed one up. Don't use your fingers for this. That's somewhere near. So a quick dummy test. That looks correct. And that looks correct. So 11 mil in, 11 mil in. Right, okay. So that's the datum for my first hole. And I've got 2 blocks where it's 11 mil in, 11 mil in from this end. The other 2 blocks, it's going to be 11 mil up and 11 mil in from the other end, but we'll cross that bridge when we come to it. There's 2 left and 2 right-handed blocks basically. So out with a wobble pin, and I think we'll have a centre drill in there first. What we got here, we don't want anything massive. That'll do nicely. So the first time using the chuck that came with the mill. Yeah, it seems alright. It came with a chuck and an arbor. You had to put them together. It's a Sanou, S-A-N-O-U chuck, B16, 3 to 16 millimeters. So yeah, what can I say? It's a chuck. It's a keyed chuck. We'll see how it performs. Just check that my axes are all locked. Yes. Okay. Right. Undo my quill, and we're just going to use this like a drilling machine. Let me get a little bit of cutting compound, cutting fluid I should say. If anyone knows where I can get one of those little anti-spill pots and, you know, like a pack of 20 of the little acid brushes that people use, you know, UK website preferably, then yeah, let me know in the comments, guys. I've looked around and, you know, all the acid brushes seem to be coming from the US. Yeah, and then you run into all sorts of problems with delivery and import tax and God knows what. When I order stuff from the US, I always try and avoid it. Strangely enough, it seems to be easier to get stuff from China than it is the US. So yeah, that's the first one done. Just swap over to the second one. There we go. Okay, now this is going to be a drilled and countersunk 8mm bolt, 8mm Allen bolt. Okay, I want to drill it and countersink it for this 8mm Allen bolt. We're going to have to make some 8mm T-nuts at a later date, but that's another story. Okay, so yeah, we want clearance on an 8mm, and then we're going to have to counterbore it for the head. Now I do have some a set of counterbores for metric Allen bolts. So I'll pull out the 8mm one, see what the pilot is on it, and that's the hole I'm going to have to drill in the block. So bear with me 2 seconds, they're only behind me here. That looks like the one. Here we are. Right, okay, I've written the pilot drill size on the box. So yeah, 8.2 mil. So I think we'll put something like a 6 through and then an 8.2. Yeah, well, I'll go straight in with an 8.2. Let's see how it handles it. Yeah. So just going to my tin. 8.2 millimeter drill. Here we are. Looks okay. Right, I'm going to have to just loosen my column off and wind the column up. Give myself enough headroom to get the drill in. Yeah, it is harder to wind up than come down, but obviously coming down you've got gravity on your side with the weight of all the head and what have you. But yeah, it doesn't seem to cause me any problems. So I've seen people put these shock absorber things, what they call it, the easy lifts off the tailgates of cars, those things on the back. Yeah, I'll see how we get on with that. I think I'm going to have to slow things down a bit here. So I've tried this sport drilling. I'm just going to lock the column again and just hand feed it through using the quill. Just get through that centre drill first. The reason I'm swapping block to block all the time is because it's easier just to quickly change the block than it is to lift the head up and down all the time. Hence why I'm sort of doing it in step-by-step method. So instead of just changing over to the counterbore now, chances are I'll have to bring the column down. So I'll just swap to the other block, drill that, and then we'll bring the head down and do the 2 counterbores. Then we'll move to the second position. I'm being very gentle with this, being very kind to it. Didn't realise you can't quite see what I'm doing with my arm on the handle. But it's drilling quite nicely. Probably speed up a touch. Yeah. Just about to break through. I'm well clear on my parallels. Okay, so 1 down, 1 to go. Let's get all my muck out of the way here. Did make quite a mess. Oop, come out. Okay. Well, you get the idea. You saw I brushed all the swap out of the way, so I'm sitting back on the parallels. Yep. And we can drill the next one. I'll just be a bit more what's it with this. Don't want to force it, I'm just letting the drill do the work. Seems to be quite controllable with this quill. Okay, that's out the other side. So swap over to the counterboring bit. Now last time I did this with a 12mm one, I had it quite a bit of chatter. So I don't know, and that was in a collet. So we'll see how we get on. Drill chuck's not ideal for this, but it should do it. You know, it should be fine. Probably best in a collet, but we'll see. I think it breaks maximum sort of end mill size is 16mm, I think, on the machine. And the diameter of the 12mm one I think was much bigger than 16, so it could be that just the diameter was up too high. Let's have a something like that. Right, I'm going to have to mess about with the depth on this. I brought my head down too far. Yeah, no vibration at all this time. I think probably the easiest one. What I do like to do is drop the Allen bolt in the hole to gauge your depth. I think what I'll do is if I measure how deep the head is, let me get in the light, it's around 8mm. Okay, so if I aim for 8.5mm deep, and my rule here is I believe 1mm thick, is it? Yeah. So let's just do a quick trick. So from the point where that touches the rule, set a 0 on the little DRO on the quill, and I'm aiming for 9.5mm deep. So, okay. That's 5, 6, 7. That's it, 9.5. Right. Change blocks over to the next one, and the same again. Okay. Yeah, I'm doing it step by step, saves me moving everything around. If I had a DRO, which I will have one of these days, not too distant future, obviously it would be a lot quicker because I could go from one spot to the next and back to the same spot with confidence. Ooh. That's good. Yeah, but as I haven't got a DRO, this is the method I'm using. Right, 9.5 again. Six, 8, 9.5. Okay. Just a thought. I didn't check the first one. Yep, just below surface. That's brilliant. Okay, happy days. Right. So I wanted to wind that way. Take the backlash out, reset a 0 on my dial, and come back towards myself 3mm. 8mm is the position, this is 11, so it's going to be 3mm. So that's one full rev on the hand wheels, 3mm pitch on these lead screws, or table screws, that's 1mm. 1mm, one turn. Right, so I'm now 8mm from the front, and let's just calculate the distance between centres. Well, I think that's about it for this one, guys. We don't want to make it too long. So as you can see, the new clamps are coming along. I haven't quite explained my methodology or how the clamps are going to operate. That's to come in the next one when they're a bit closer to completion. Yeah, I got some clamps to make yet. I got some T-nuts to make with an M8 thread in, and that'll all be coming on the next one. Quite a few new subscribers have come on board, so welcome to you all. And as I usually say, thanks for subscribing, thanks for watching, and we'll see you all very soon. Cheers now.